Hi boys and girls, today we are going to be learning how to find the simplest form of a fraction. This is important because fractions can get very large very quickly. Um, and we know that we can name fractions different names and it's the same amount, just the pieces are different sizes. For help with that, you can find the equivalent fractions video, which can help to explain why we can take a larger numbered fraction and call it a different name, but it's the exact same fraction, just being called in a different name. These are the steps I'm going to be using, and these are the rules. I have examples that I'm going to be taking us through, and as we go through those examples, you'll see how these steps work, and we have examples that will use each of these types of rules. Now, as a side note, if you're the kind of student that can look and see a larger number than two numbers can be divided by, great, use that. I'm going to be taking the method of a very slow, methodical, easier route that doesn't require you to know your 9s and your 12s quite as well as just knowing your 2s and your 3s. Now, step 1 and 2 will be used for 90% of the time. Most of the time, you don't have to go any further than dividing by 2 and dividing by 3. But make sure that you are checking your 2s and your 3s. Also, make sure that both numbers can be divided by 2 or both numbers can be divided by 3. You cannot do the top number by 2 and the bottom number by 3. As I do examples, it'll become more clear. The first example we're going to start with is a nice, easy set of numbers. They're not small numbers, but they're very familiar. 24 and 36. The first step is always the same. We check 2. We have 24 and 36. Can they both be divided by 2? You should know they can because they're even. So you divide the top and the bottom. Whatever you do the top, you have to do the bottom. That is an important idea in fractions. You do it to the bottom, you got to do it to the top. All right? Always, same number divided by 2 has to be divided by 2. 24 divided by 2 is 12. 36 divided by 2 is 18. Not done, but I do start again. Can they both be by 2? Yes, because they're both even. 12 divided by 2 is 6. 18 divided by 2 is 9. Start again. Can they both be divided by 2? No, because 9 is odd. So we check 3. Check 2. If that doesn't work, check 3. And you should know 3, 6, 9. Yes, those are some of your 3s. Divide by 3. Do it to the bottom. You got to do it to the top. You get 6 divided by 3 is 2. 9 divided by 3 is 3. Now we check. We also can use our rules. The number 1 rule says if the numerator is 1 less than the denominator, you know it's in simplest form. Meaning 2 is 1 less than 3, 4/5, 5/6, 199 200ths. If they are 1 apart, you know this is in simplest form. So 24/36 in simplest form is 2/3. We're going to look at several more examples to make sure that we understand. 27/30. Check 2. 27 does not work because it's odd. 30 does, but they don't both. And remember, you have to do the same number. So where do we go from there? Check 3. And hopefully you recognize that 27 and 30 are both of your 3s. Divide by 3, divide by 3. And we end up with 9/10. Nice, easy one. Told you, most of the time you only have to do your first 2 steps. And our rule, if the numerator is 1 less than the denominator, 9 is 1 less than 10. So 9/10 is 27/30 in simplest form. We're going to do several examples. Let's try 21/27. Check 2. They're both odd, they don't work. Check 3. Do they work? Yes, they are both in our 3s. If we count by 3. Divide by 3, divide by 3. I get 7/9. Is that in simplest form? Check 2. Nope, they're odd. Check 3. 7's not one of my 3's. So I'm going to check my rules to see if maybe I'm in simplest form. Is the numerator 1 less than the denominator? Nope. Is the numerator a 1? Nope. Are both of the numbers prime? Nope. Have I tried up to the numerator? Well, I tried 2. I tried 3. I get to skip 4 because 4's will only work if 2's work. So once you said 2 doesn't work, 4 won't work. I have to try 5. Does 5 work for both of these? No. I get to skip 6 because if 2 and 3 didn't work, 6 won't work. So I have to try 7. Oh, I've tried up to my denominator. There's my rule 4. I've tried up to my denominator. Therefore, I know this number is in simplest terms. 21/27 is simplified into 7/9. They're the same amount, just a different name, different sized pieces. Our next example that we're going to be looking at is 14/21. Now, I said most of the time that you're doing this, you're going to be checking just 2's and 3's. My examples are specifically designed to take us through several of the steps, but you'll find that when you're doing your homework or your assessments, most of the time, sticking with 2's and 3's, you're going to be right on. Check 2, 21 makes that not work because it's odd. Check 3, 14 is not one of my 3's. Check 5, they don't identify to 0. Check 7. I recognize that these are my 7's. 14 divided by 7 is 2, 21 divided by 7 is 3, and 2 is 1 less than 3, so I know I'm in simplest form. My next example that I'm going to show is 5/77. Check 2. They're both odd. Check 3. Do you remember the rule for being able to quickly check 3? Add both the digits together, and if it's one of your 3's, it can be divided by 3. So 5 plus 5 is 10, not one of my 3's. 7 and 7 is 14, again, not one of my 3's, so 3 doesn't work. I get to skip 4 because 2 didn't work. Does 5 work for both? Top number, yes. Bottom number, no. I get to skip 6 because 2 and 3 didn't work. I have to try 7. Does 7 both work? Works for the bottom, but not the top. I get to skip 8 because if 2 doesn't work, 8 doesn't work. 10 is easy to see, but if 5 didn't work, 10's not going to work. That's why we get to skip 10. And I have to check 11. Those are my doubles. Divide by 11, divide by 11, I get 5/7. Is it in simplest form? Are they one away from each other? Is there a 1 in the numerator? Are they both prime? 5 and 7 are both prime, which takes me to rule 3 for checking for simplest terms. And yes, 5 and 7 are both prime. Therefore, I know that 55/77 is simplified as 5/7. Last problem that we're going to look at is 13/39. These are a very rare type, but they do appear, and I want to make sure we know how to go through all of those steps. We like the ones that we stick up here with our 2's and the 3's, but every once in a while you're going to get one like 13/39 that you might think, oh, it's already in simplest form, but it doesn't follow those rules, and rule 4 requires us to try all the way up. So we ask ourselves, 2? No, because they're odd. 3? 13 is not one of my 3's. I get to skip 4. 5? Don't end in 0 or 5. I get to skip 6. These are my 7's. No, 7, 14. I skipped right over 13. I get to skip 8. I get to skip 9. 10 doesn't work because 5 didn't work. Are these my 11's? No, because my 11's are my doubles. So my last rule says to check the numerator. See if you can take the numerator and divide it into the denominator. And when I said that, I'm sure several of you went, oh, look, 13 does divide into 39. Divide by 13, divide by 13, I get 1/3. Which also takes me to my rule 2 for checking to see if it's in simplest terms. If there is a 1 in the numerator, I know that I have reached simplest form. That's how we find simplest form, boys and girls. Watch the video as many times as you need to make sure that you know how to find